Hello, my lovely students. So, section 4.1, like the name of the chapter is solving trig equations, but we're not actually going to solve trig equations till the end of the chapter. What we're doing right now is verifying trig identity. So, a lot of this is to get you used to using these different identities, getting very comfortable and familiar with them. Some of them we've been using already. You're just going to be using them more. So, Pythagorean identities. Sine squared plus cosine squared equals 1. And the other two, the quotient identities. Tangent is sine over cosine. Cotangent is the reciprocal of that. Our reciprocal identities, particularly those. Because if I know those three, I know the other three. Don't need to know 6, just need to know 3. And then there's the even odd identities, which they really don't come up that often. So it's just like these two down here absorb the negative sign. And then all the rest of these, the negative sign comes out. Because these are all odd. And these down here are even. All right. So we have a lovely how to, given a trigonometric identity, how to verify that it's true. So these are going to be typically equations. You are trying to take one side and show how it can turn into the other side. So this means we don't interact the two sides. The reason we do it that way is because there's some things you would do to both sides of the equation that make sense from where you're going down, but to prove an identity is true, you actually have to start from the bottom and work backwards. And some of those steps that we use going down do not work in reverse. They're not guaranteed to work. Most of the stuff we do, though, it would work. And there's ways to kind of use the idea of cross multiplying without actually cross multiplying. So we'll get to one of those eventually. So one of the things is work on one side of the equation and start with the side that's more complex. It is easier to reduce and simplify than it is to figure out what you need to multiply by. Look for opportunities to factor expressions, square a binomial, add fractions, yeah. Note which functions are in the final expression and like try to head there. And then worst case scenario, if you don't know what to do, write everything in terms of sine and cosine and then go from there. All right, so our example here, verify this identity. So we have tangent of theta times cosine of theta equals sine of theta. So we're going to take the left side because there's more going on there and see if we can show that equals sine theta. All right. So not much here, but I do know tangent in terms of sine and cosine. The tangent of theta is the same as sine of theta over the cosine of theta. And now I have sine over cosine times cosine. Technically, it's times cosine over 1. But a cosine on the top, a cosine on the bottom, they cancel out. And we are left with sine theta, which equals what we wanted to prove, sine theta. Done, however you want to mark that. I know some people do a little square and kind of fill it in. Or QED, thus it is shown. All right, just like that. So now we've got a slightly more screwier looking identity, and it is supposed to equal 1. We're not starting with the 1 side. All right, so whole lot going on here, but I'm going to take everything that's not sine and cosine and write it in terms of sine and cosine. So cosecant is the reciprocal of sine. And a cosine is just going to copy down. And then tangent, again, sine theta over cosine theta. And now look at that. The cosines cancel as they did in the previous example because it's just an expansion on the previous one. And the sines cancel. So we have 1 equals 1. Done. All right, now example 3 here is actually using those even odd properties. Sine is odd graphs, negative inside can also be outside, like you can yoink it and move it outside basically. So here, sine of negative x is the same as negative sine of positive x. So I'm going to make that substitution here. Everything else, though, I'm going to keep the same. So 1 plus sine x, 1 plus, and this is where we're going to put in instead. Now we have negative sine x. So I can really write this as 1 minus sine x. And this is 1 plus sine x. All right, now my left side has no parentheses and I have a square. I have 2 things in parentheses, so let's multiply. And I can see I'm going to get a sine squared there, so we'll go with that. So 1 times 1 is 1 minus sine x plus sine x and minus sine squared x. All right, so these 2 guys in the middle cancel each other out. We're left with 1 minus sine squared x, which that is how a difference of squares factors. So it's expected we should end up with something like this. Now, 1 minus sine squared. So that is equal to cosine squared, but you need to be able to prove why. So remember our Pythagorean identity, the big one, sine squared plus cosine squared, as long as the angles are the same, is always 1. Since this is a true given identity, I can manipulate it. I can subtract things to the other side, like divide everything by something, whatever I want. So over here, I have 1 minus sine squared. So I'm going to manipulate my identity by subtracting the sine squared from both sides. We now have cosine of x squared is 1 minus, I should just say it's sine squared. So cosine squared of x is 1 minus sine squared of x. And 1 minus sine squared of x is what we have here, equals cosine squared. We have done the thing. All right, now this one is asking us to verify the identity, and we got a whole bunch of secants, like good Lord. All right, let's do what we're gonna do. So, obviously we're gonna take that secant side and mess with it. I'm gonna go ahead and write it in terms of cosine. It's gonna look a little ugly, but then I think you'll see like what we can do next, sort of. All right. So secant squared, secant is 1 over cosine, so secant squared is 1 over cosine squared. and then the minus 1 over 1 over cosine squared. Now there's two ways to look at this. One is to see that we have a mess on top divided by this fraction. So we can simplify that by changing it to multiplying by the reciprocal. The other thing we can do, and this will look a little weird, so I'm bringing it up because it's actually a really neat tool once you get a handle of it, is I can multiply the top and the bottom of this fraction by the same thing. And so I'm going to do it that way just to kind of show you guys what that looks like. So when I have a bunch of fractions, I figure out my common denominator, and then I multiply, like when I have little fractions in a big fraction, I multiply the big fraction by the common denominator over the common denominator. Now, on the bottom, those are going to cancel out. And on the top, we're just multiplying by cosine squared, which is what we would have had if I flipped the fraction over. So it's just a slightly different way of getting to the same thing. Now this is cosine squared times 1 over cosine squared is 1, minus cosine squared times 1 is cosine squared. And just like 1 minus sine squared is cosine squared, 1 minus cosine squared is sine squared. I can rewrite that identity either way. So this is shown. Example 5, we're given an expression and given the directions to rewrite it just in terms of sign. So we got to play around with this to try to figure out a way to do that. But first things first, let's just write it all in terms of sine and cosine and see what we got. So 2 tangent is sine theta over cosine theta. Secant is 1 over cosine theta. All right. So I got that sine on top. Cool. I can keep that. On the bottom, I'm going to have cosine squared. Oh, we've been playing with that, haven't we? Yes. So now I have 2 sine theta over cosine squared theta. And then in place of that cosine squared, I will write 1 minus sine squared. Now, part of you may be asking, like, when are we going to use this? We're not that much, but like being familiar with the manipulating cosine squared is the same as 1 minus sine squared. You are going to use that a lot. The fact that 1 minus sine squared or 1 minus cosine squared factors into 1 plus sine times 1 minus sine, or 1 plus cosine times 1 minus cosine. So they don't come up a lot, they do come up. All right, I'm going to pause it here and then we'll do the rest in another video.